What's up, mathematicians? Today we're talking about how to multiply numbers with decimals. How exciting. And we actually do this quite frequently. Well, at least grown-ups do, and maybe kids do too. The most frequent example of multiplying with decimals is when we use money. And I'll give you an example right now. I have a student who collects baseball cards, all right? Now let's just pretend this student wants to add to his baseball collection and wants to buy 7 baseball cards at the store. He's at the store, he wants to buy 7 baseball cards, and each baseball card costs $1.50. Well, we've got a decimal here. And so the first thing we're going to do is set our problem up. He's going to buy 7 baseball cards and each is $1.50. And if we want to multiply these numbers, this is what we're going to do. So first, we are going to put, I usually put the number with more digits on top. So I'm actually going to put 1.5 on top and 7 on the bottom, and we're going to multiply them. Now, one thing is that when I'm teaching how to multiply with decimals, setting up the problem is something that initially can be challenging for students because they want to line up problems either like this, which, by the way, you can actually do it like that, and I'll explain why later. Or they want to line it up like this, or they want to line it up like they often do. I see this a lot, the 7 and then the 1.5. They line it up like that. Now, when we're doing standard algorithm multiplication, the best way to line it up is as I've done so right here, with the number with more digits on top and the one with fewer digits on the bottom. And that's what works best for me. So here's what we're going to do. We are going to multiply these two numbers as if we would multiply 15 times 7. Like we're totally ignoring the decimals. See this decimal point? We're kind of ignoring it right now. We're just going to multiply 15 times 7. And what is 15 times 7? Let's do it. Well, 7 times 5, I know that that's 35. I'm going to carry the 3. Now I'm going to multiply 7 times 1, that's 7, add 3, that's 10. So now my answer is 105. So where do I put the decimal point? Well, the answer is you count. So you look at both factors and you count how many digits are to the right of the decimal point. Now here I only have 1 digit in my factors, that is to the right of the decimal point. And so what I'm going to do is I'm going to move the decimal point 1 digit in. So basically the rule is the number of decimal digits in your why did I circle that? The number of decimal digits in your factors, in both factors, will be, you add those up, and that will be the total number of decimal digits in your answer. Let's keep going. Let's do another problem. Let's do, what if I have 0.15 times, let's do 7.2. Okay, so I notice how I lined it up. Again, I kind of lined it up as if I was ignoring the decimal points, as if I was actually multiplying 15 times 72. Okay, and by the way, if you want to use the box method or partial product multiplication, you can do that too. Use the method that works best for you, and just multiply the numbers, the factors, as if you were multiplying the regular whole numbers. All right, let's get to it. So first, I'm going to multiply 5 times 2. That's 10. I'm going to carry the 1. Now I'm going to multiply 2 times 1. That's 2. And I'm going to add the 1. That's 3. Now I put a 0 here because I'm moving on to the tens place. I'm going to cross this out because I don't need that anymore and I don't want it to confuse me. I'm going to multiply 7 times 5. That's 35. I'm going to carry the 3 here. Now I'm going to multiply 7 times 1. That's 7. Add 3. That's 10. Now I'm going to add these numbers up just like I would if I didn't have decimals in my problem. And you can see I've gotten, I have the number 1080, but I haven't applied the decimal points. So now we got to count the decimal digits. Well, we've got one decimal digit, another decimal digit, in this factor. So that's 2 there, and then another decimal digit there. So that's 3 decimals, 3 decimal digits, I'll say, which means I'm now going to go down here to my answer, and I'm going to go 1, 2, 3. And that's where the decimal point goes. Another way to think about it is if I have these 3 decimal digits, I'll have an equal number of decimal digits in my answer. 1, 2, 3. So now my answer is 1.080, which is the same as 1.08. So it's up to you if you want to keep that 0 there or not, but that's what we've got. So 0.15 times 7.2 equals 1.08. Another way to say that is 15 hundredths times 7 2/10 equals 1 800ths. Okay, let's use another real life example. Okay, let's say I have, well, sometimes, not very often, but sometimes I like to cook. And I recently learned how to make lasagna. So let's pretend that I need to make, I'm going to work on writing better 3s, 3.5 batches of lasagna, 3.5 batches of lasagna. Let's pretend I'm going to some potluck dinner and I'm bringing I need 3.5 batches of lasagna for the number of people that are going to be there. And each batch, let's pretend each batch needs, let's pretend it's 0.5 or 0. Let's just say 0. Let me write that better. Let's do 0.5 cups of tomato sauce for each batch of lasagna. I don't think that's an accurate number of cups of tomato sauce, by the way, but we're not trying to be perfect chefs here, are we? We're just trying to practice some decimal multiplication. So the first thing I need to do is say, okay, what is my equation? Well, my equation is going to be 3, there I go with my 3's again, 3.5, so 3 batches times, and we're trying to figure out how many total cups of tomato sauce I need to make my 3.5 batches of lasagna. I can't remember if I mentioned that, but I mentioned it now. So 3.5 batches of lasagna, with each batch requiring 0.5 or half a cup, 0.5 cups. How many total cups of tomato sauce will I need? Okay, 3.5 times 0.5. Well, I tend to use standard algorithm for multiplication, so let me set my problem up. Now, it's your choice whether or not you want to keep the 0 here, all right? You don't need it. If you do the problem with the 0, it actually won't affect your answer, but it's kind of extra work if you do, so I'm just going to actually erase it because I don't need that 0 there because I can do the problem with just 3.5 times 0.5. I'm already noticing that my answer is going to have 2 decimal digits because I have my factors 1 there, and 1 plus 1 equals 2. Okay, let's do the problem. Well, 5 times 5, that's 25. Carry the 2. 5 times 3, that's 15. Add 2, that's 17. My answer is 175 for now, but I have not applied my decimal point. I am going to have two numbers past the decimal point, which means I need to put the decimal point here, right after the 1, which allows me to have two numbers past the decimal point. So in all, I'm going to need 1.75 total cups of tomato sauce to make my 3.5 batches of lasagna. So now, because I know how to multiply with decimals, I can go ahead to the store and know exactly how many jars of tomato sauce or cans of tomato sauce I might need. So this is how we multiply with decimals, on a regular basis. Now, I'm trying to think of, what if I have, let's do some more examples. What if I have 1.03 times 2? Actually, not times 2. Let's do times 8. 1.03 times 8. How would I set this problem up? Well, if you thought to yourself to set it up like this, well, assuming you're doing the standard algorithm multiplication, you would be correct. And like I said, it doesn't matter which method you use as long as you apply the correct number of decimal digits in your final answer. So let's do this problem out. Well, we've got 8 times 3, that's 24. Carry the 2. 8 times 0 is 0. I add 2. Now 8 times 1, that's 8. And now I need to count the decimal digits. I've got, 8 doesn't have any decimal digits. It's just 8. But I've got 2 here, so my answer is going to have 2 decimal digits. So let me insert my decimal point so that it allows for 2 decimal digits. So my answer is 8.24. So 1.03 times 8 is 8.24. All right, so I think we've covered the basics, and we're going to keep working on it and working on it and working on it until we know it really, really well. Why? Because practice makes progress. All right, till next time, mathematicians.